Hey guys, we're solving rational equations today, okay? I know these look a little scary because we've got variables in the denominator and it just kind of spooks us a little, right? But guess what? We are actually going to get rid of the fractions. You heard me right, okay? So what we're going to do is I'm going to show you a quick example that we're actually not solving, okay? Anyways, you'll see. So if I had a problem like this, right? Don't worry, we're not actually going to solve it. That big fraction is a little intimidating, right? So one strategy I could use if I were solving this would be to multiply both sides by 5. Because then what happens? Guess what? The 5s on this side cancel. This becomes a 50. And then doesn't that look a little less scary to solve? I mean, it's still got a lot of things going on, but there's not a ginormous fraction, right? So we're going to be doing something very similar. Okay, so the first thing we're going to do is we're looking for the LCD, which is the least common denominator, okay? This is like when you're adding or subtracting fractions, say that you're adding 1/2 and 1/3, right? And you need to get the denominators the same. We're doing the same thing, just with a little bit scarier things, right? But it's gonna be okay. So if I were adding these, my least common denominator would be 6. Right? That's the smallest thing they both go into. In this case, I just multiplied the denominators to get 6. Now, that is not always the least common denominator, but oftentimes it is, okay? So in this case, my LCD is going to be x plus 4 times x minus 2, okay? Now, I should say we should always check to begin with if we can factor anything, but this is already all factored and I can't factor anything, right? So my least common denominator is going to be x plus 4 times x minus 2. Now watch what happens when I multiply both sides by that, okay? So I'm going to multiply this side, x plus 4 times x minus 2. If I multiply one side, I got to multiply the other side, right? X plus 4 times x minus 2, okay? Now watch what happens when I multiply that. Guess what? This and this cancel, right? So then on this side, I'm just left with 2 times x minus 2. What? No more big, ginormous fraction. Okay, and what happens on this side? The x minus 2's cancel, and I'm left with 8 times x plus 4. Oh my gosh. This is way less scary, right? You've probably solved things like this a million times. I'm going to distribute. So I get 2x minus 4 equals, I'm going to distribute on this side. So I get 8x plus 32. Okay. Then I want all my x's together. So I'm going to subtract 8x from both sides. So I end up with negative 6x minus 4 equals 32. Remember, I want x alone. So first I'm going to get rid of this 4 by adding it to both sides. And then these are being multiplied, so I'm going to divide that negative 6 off. And I end up with x equals negative 6, okay? Now, the last step, you're like, oh, I thought I was done. Almost, you're almost done. But something you cannot forget. Whenever we start a problem with variables in the denominator, we have to check and make sure we don't have any what we call extraneous solutions, okay? So an extraneous solution, for example, would be if I had gotten the answer, I'm going to write it in red so you know this is not the answer. If I had gotten the answer x equals 2, okay? Pretend I solved down and that was my answer. Well, if I went back and tried to plug that in, I would get 2 minus 2, which would make this 8 over 0, right? And zeros in denominators are like the worst thing in math, right? Like we don't even. So if I had gotten x equals 2 as an answer, then it would be an extraneous solution and it would not actually be a solution, okay? If you want to see an example where I do have an extraneous solution, I will link one for you in the corner, okay? But we're good here. One thing that you might want to do is figure out what your extraneous solutions would be to begin with, okay? So you can do it this way where we solve down, we get our answer, I check, okay, it's not going to be an extraneous solution in either of those cases, right? Another thing we could have started by setting both of those equal to 0, because that's what they can't be, right? Oh, that's not how that should be. X minus 2 equals 0. Then I would get x equals -4 and x equals 2. So then I would know if I get any of those answers, they're extraneous. So we could have done that from the beginning, or go ahead, get your answer, plug it in, and make sure none of them are extraneous, okay? I'm going to X these off so you know those weren't the answer. My answer for this problem was x equals -6. All right, hope this made sense. Thanks.